The company, the company had the following results for the past 5 years on its portfolio, with our years and our annual rate of return, which is HPY. Then after that, in addition to the statistics provided above, inflation averaged 7% and interest rates are projected to average 12% for the next 3 years. First things we need to do is we need to compute the standard deviation for the results. So colleagues, whenever you see inflation, okay, remember inflation also erodes your returns. Apart from eroding the purchasing power of money, also your returns get eroded by inflation. So we need to make adjustments for our returns. We get our real returns, the returns adjusted for inflation. Okay. So if you remember this formula, one plus the real interest rate equals one plus the nominal interest rate over one plus the inflation rate. So here, the interest rate which we're talking about is this HPY here. All right. So we've just taken this one here over the equal sign, and this is what the formula becomes. Okay. Our real HPY is 1 plus the nominal HPY over 1 plus the inflation rate minus 1. Okay. If you forget this formula in the exam, you can just simply subtract the inflation rate, just minus 7, minus 7. But this one will give you a more accurate value. Okay. Yes. So first things first, we need to adjust our returns. Here, then we've got our HPY, annual HPY. Then we have our adjusted HPY, the one which is adjusted for inflation. Okay. So for 2017, our HPY is 11%. So now we need to adjust it. All right. So we're going to say 1 plus, let me put the formula here. So this is like our nominal HPY. The nominal HPY is just your HPY without the adjustment for inflation. So you're going to say 1 plus 0.11 divided by 1 plus the inflation rate 0.07 minus 1. So let's get our calculators. 1.11 divided by 1.07 minus 1. What value do we get? Yes, 1.11 divided by 1.07 minus 1. Are we there, colleagues? I'm just responding to some messages, so that's why I'm asking if you could do the tabulation. Just tell me what value you get. No one has come with a calculator, Madam. Let's see, Madam Juliet, Mr. Francis, Madam Mary, Madam Patricia. Okay, let me do the tabulation. 1.11 divided by 1.07, you get 1.037 minus 1, you get 0.037. 0.037, which is the same as 3.7%. Okay, so after inflation, when you account for inflation, your actual return is 3.7%. Okay, and as I said earlier on, if you forget this formula, 11 minus 7, you're supposed to get 4%. Okay, so the answers are almost close. It's just that this one's more accurate. This one will give you like a rounded off figure. Okay, so here is 0.037. So we'll keep them as decimals. Okay, we go to the next one. 7%, 2018, 7%. So we use the same formula here. 1.07 over 1.07 minus 1, get 0% basically here. And in 2018, due to inflation, it's like you have not earned any return. The inflation has taken out all the return. 2019, negative 6%. So here it's going to be 1 minus 0.06. We said 1 plus 0.06. Negative here. 1 plus negative 0.06. Over 1 plus 0.06. 0.07. So 1 minus 0.06, that should be 0.94 divided by 1.07 minus 1. So 0.94 divided by 1.07, you get 0.87 minus 1, negative 0.12. Okay, so here negative 0.12. 2020, 12%. So when it's 12%, it's the same as saying 1.12. Okay, 1 plus 0.12 divided by 1 plus 0.07. So 1.12 divided by 1.07, 1.046. 1.046 minus 1, that is 0.046, or 0.047 actually, if we round it up, 0.047, 0.047. 2021, 4%. So 4%, we're going to say 1 plus 0.04, that's 1.04 divided by 1.07 minus 1. So 1.04 divided by 1.07, you get 0.97 minus 1, negative 0.28, negative 0.028, which is like 2.8%, negative 2.8%, negative 0.028. Okay. So in the question it says interest rates are projected to average 12% for the next 3 years. So I'm assuming they're talking about these HPYs. So 2022, 2023, 2024. So here 12%, 12%. So we've already seen 12% is 0.047. So we'll put it here. 0.047, 0.047. So here's 0.047. Yes. Colleagues, any questions? Any questions? Let me actually put these as number. take this to Excel. Now we can compute the standard deviation. Okay, so first things first, before you get the standard deviation, you get the mean, the average. So we get the average first. Just add all these numbers, 0.07. And how many years do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 years. So divided by 8. So our average return is 0.0096. That's our average return, which is 0.96%. Okay, if we want to convert this into percentages. So this is our mean. Once you've got your mean, first, before I go further, any questions? Okay, so once you've got your mean, you bring it here. Zero point zero zero 0.00962. You're going to subtract every return with the mean. Okay? Every return you're going to subtract it with the mean. Okay, so we'll call our adjusted HPY is X, then our mean, we'll call it X bar. Okay. So here, I'm just subtracting each adjusted HPY with the mean HPY. Okay, basically we're getting the deviations. Okay, when you subtract every value from the mean, you get the deviation. So 0.0037 minus 0.009625, get this. 0 minus 0.009625, get that. Okay. Each value, we are subtracting it with the mean. Yes. Then after you subtract now, we have to square these deviations. Okay, we square the deviations. Okay, each of these values we're squaring them. Just hold on, colleagues, let me get this call. Hello? Hello? Yes. Okay, sorry, colleagues, about that. Okay, so yeah, as I said, we're squaring each of these deviations, squaring them. Yes. Okay. Any questions so far? All right. After you've squared the deviations, then you just get the total. Okay. Sum. This is our total 0.0246. It's appearing like this. Then finally, the formula that we're going to use to get our standard deviation equals the square root x minus x bar summation of x minus x bar squared over n minus 1. Okay, so in this case, this summation of x minus x bar squared, it's this value we got here, 0.02464. Okay, so it's a square root over 0.0246 divided by n. Since there are 8 years in total, divided by n, 8 minus 1, divided by 7. So 0.0264 to 0.0246 divided by 7, we get 0.0035. So we get the square root of 0.0035. 0.0035. The square root of that. The square root of 0.0035 is 0.0059. In percentage form, that is 5.9%. And that is our standard deviation. 0.0059. Any questions? Questions, queries? We'll move to the next question. Just question 4. So I'm first focusing on the questions with calculations, then the theory will be next afterwards. Okay. So question 3 was theory, question 4 is calculations. All right, we can go to question 4. Mukula PLC's dividends per share are expected to grow at 10% compounded rate for 5 years and at a 6 thereafter at a 6% rate. If the current dividend DO is 2 kwacha per share and the required rate of return KE is 14%, what is the value of the stock? So, colleagues, we must remember the concept behind stock valuation and also bond valuation. Okay. The price of a stock is the present value of its all the future dividends it's expected to pay. Okay. The price of a stock, how much you should pay for a stock, is the present value for all the dividends that stock is expected to pay in the future. Okay. So here, as I said, when you're dealing with stock valuations, there, there are three scenarios you can be given. There's the no growth model, where there's no growth rate, so it's not the one we're dealing with. There's the constant uh, growth model, where the stock is just increasing by one rate forever. Then you've got this one, the multiple growth phase model, where the growth rate changes 5% this time, then 6% another time. So this is the one which we're dealing with because this stock has got two growth rates. So when you're dealing with these questions, first things first, you need to calculate the expected dividends. Colleagues, what's the formula for the expected dividend? Today we're too quiet. I do not know why we're quiet. Hmm. Mr. Muhang, how do we find the expected dividends? Madam Patricia, how do we find expected dividends? Madam Mary, the two, Madam Ma- Hmm? Mm-mm. Hold on, madam. You have gone first. You've jumped. But thanks for your but you've jumped. The present value will come after you get the expected dividend. Okay, madam? The present value will come after you've got the expected dividends. So the first, yes. Yes. Uh-huh. You're very correct there. What's the formula for getting the expected dividend? Although mm, it's not the formula related to the growth model. Colleagues, this was in your assignment, assignment 2. Okay. It's similar to us, the question in assignment 2. No, thank you for your contribution, madam. Okay. This is the formula here. So I believe I've already got the workings here. Okay. So DO is 2 quach 1 plus the growth rate is 10%, so 0.1. Okay, so you're going to say 2 multiplied by 1.1, 1.11. Okay, have this in 2 times 1 for the first year, year 1, 2 times 1.1, 2.2. Year 2, you say 2.2. This amount here, 2.2 times 1.1, you get 2.42. Year 3, 2.42 times 1.1, 2.66. Year 4, 2.66 times 1.1, 2.93. Year 5, 2.93 times 1.1, you get 3.22. Any questions on that? What is the next thing we need to do? What is the next thing we need to do? I believe everyone handed in assignment 2. And when you're handing assignment 2 in, you are seeing what you put. Um, hmm. Next, we need to account for the dividends for after year 5. The dividends from after year 5 to the foreseeable future, which is called the terminal value. Because remember, for 5 years, it grows by 10%. Then after 5 years, it's going to grow by 6%. Okay, till the foreseeable future. Okay, thereafter. So this is where we bring in the terminal value. Okay, terminal value. Okay, so the terminal value, remember, it's the latest dividend, which is paid in year 5, plus the growth rate over the cost of equity minus the growth rate. Okay, which is done here. Okay, the dividend for year 5, 3.22. The growth rate is 6%. So 0.06 plus 1, that's how you get this 1.06. Divided by 0.14, the cost of equity, minus the growth rate, 0.06. you get 42.66. Any questions? Any questions, Mr. Crucial, Mr. Muhango, Madam Patricia, Madam Mary, Madam Juliet, Mr. Francis? Any questions? Then after that, now we can get the present values. Okay, the present values of these expected dividends for year one up to year five, and the present value of the dividends after. Okay. Yes. So remember, present value equals future value multiplied by 1 plus r to the power negative t. Or it can be future value over 1 plus r to the power t. Now, when discounting, colleagues, what are we going to use as our discount rate? What do you think we're going to use as our discount rate? Yes, Madam Juliet, what will we use as our discount rate when discounting these present values? Madam Mary, what would we use as our discount rate? Because it's very important. If you use the wrong discount rate, you get the question wrong. Thank you for your contribution, but you're going to use the cost of equity as the discount rate. Okay, going to use the cost of equity as the discount rate. Okay, so here, as you can see, this was the formula that was applied. Future value over 1 plus r to the power t. Okay, so for year one, 2.2 over 1.14. Year two, 2.2 over 1.142 to the power 2, since it's the second year. Year three, 2.66 over 1.14 the power 3, since that's year 3. Year four, 2.93 over 1.14 to the power 4. Then in year 5, all right, you include the dividend for year 5 and the terminal value. If you want, you can do them separately. You can do 3.22 over 1.14 to the power 5 plus 42.66 over 1.14 to the power 5, or you can combine them like this. Take note, for the terminal value, yeah, don't put year 6, or use the terminal value will be in the same year. as the last mm, dividend. All right. Do not put the terminal value in its own separate year. It's the same year as the last dividend. Okay. So when we discount, when we do our tabulations, the value of the stock today is 31.13 kwacha. Any questions? Okay. If you use this one, future value 1 plus r to the power negative t, you will still get a similar answer as this. All right. It just depends which one you're comfortable with. Okay. Either fv multiplied by 1 plus r to the power negative t, or fv over 1 plus r to the power t. So that is the value of the stock today.